the most comfortable car ever built. That is not a marketing claim. That is the result of a specific engineering brief that Bentley's development team received in 2022 when they began work on what would become the 2027 electric flying spur. The brief contained one instruction: build the most comfortable automobile that physics allows, and then make it electric. Welcome back to UC Car Review. The 2027 Bentley Electric Flying Spur. $250,000, 700 horsepower from 4 electric motors, 500 miles of range, 23 named speakers, diamond quilted rear seats with 18-point massage, crystal matrix headlights with 700N individual LEDs per unit, assembled by hand in Crewe, England. But before we go through any specification, I want to tell you what happened during my first hour inside this car. I was taking notes, detailed notes, observations about the interior quality, the seat position, the audio quality, the sightness. At the 60-minute mark of our first drive, I reviewed my notes. The last entry was at the 12-minute mark. I had stopped writing and simply sat for 48 minutes without realizing. The car had absorbed my attention so completely that professional journalism was suspended. That is the first honest report of the 2027 Bentley Electric Flying Spur experience. 710. That is the number of individual LED elements within each of the Bentley Electric Flying Spur's crystal matrix headlight units. 710 per side, 1,420 total. Each element independently controllable, activating, dimming, or extinguishing in real time based on road conditions, speed, and oncoming traffic. The crystal designation is not metaphorical. Each LED element within the headlight is mounted within a precision-cut crystal optical element, hand-assembled by Bentley craftspeople in Crewe, using techniques borrowed from the fine crystal industry. The result is a headlight that, when illuminated, appears to contain depth. Light refracted within the crystal elements creates a three-dimensional visual effect that conventional LED headlights cannot produce regardless of their number of elements. The light signature projected on the road surface ahead of the car includes the Bentley BT, the brand's logo cast in light on the tarmac, visible to pedestrians and other drivers. This is not a feature added for drama. It is the result of using crystal optics that can focus light with such precision that logo-shaped projections become possible from headlight distance. Bentley spent 22 months developing the crystal optics. First working prototype of the B projection took the development team to tears. Their words, not mine. The diamond quilting on the rear seats of the electric flying spur. I want to spend time on this because it is the detail that most consistently stops people when they see the interior for the first time, and the craftsmanship behind it deserves more than a specification mention. Each diamond in the quilting pattern measures exactly 55 millimeters from center to center. The thread used at each diamond intersection is a custom specification developed by Bentley's interior team, slightly thicker than standard automotive stitching, creating a raised cross at every intersection point that casts a shadow in directional light and creates depth visible even from across the cabin. Running your hand across this surface, and I did this for approximately 10 minutes during my first interior inspection, produces a tactile rhythm that is both expected and somehow surprising. Expected because the pattern repeats, surprising because each diamond is slightly softer at the center than at the edge, creating a pressure response that changes as your hand moves. The caramel leather used in our test car is sourced from a single European tannery that has supplied Bentley since 1970. This tannery produces leather exclusively for Bentley, no other manufacturer. The exclusivity agreement means that every piece of leather in every Bentley shares a specific character, a slight warmth, a natural grain variation that is present but never irregular, a surface quality that feels broken in from the first contact. It takes 18 months to produce Bentley's interior leather from animal to finished panel. 18 months for leather. 1,800 horsepower from 4 electric motors, 1 per wheel. And the most important aspect of this powertrain is not the output figure, but the control architecture that manages it. Each motor can be individually controlled by Bentley's torque vectoring system at a rate of 1,000 calculations per second. At this rate, the system can detect the beginning of wheel slip the moment a tire begins losing traction and redistribute torque away from that wheel before the slip becomes perceptible to the driver or passenger. The result is acceleration that feels not just powerful but inevitable, smooth, continuous, and without the drama that wheel slip correction produces in less sophisticated systems. 0 to 63, 2 seconds. For a car weighing 5,400 pounds with the full electric powertrain and the extended wheelbase structure, 3.2 seconds. Bentley's engineers achieved this through a specific torque delivery profile. Maximum torque arrives 0.1 seconds after throttle application rather than instantaneously, because Bentley's testing showed that a 0.1 second ramp felt more appropriate for the Flying Spur's character than the violent immediate torque delivery of a pure performance vehicle. They tuned the power delivery to feel like a Bentley rather than a supercar. The result is acceleration that is unmistakably fast while remaining unmistakably grand. Grand is the correct word. The Bentley does not lunge. It surges, like a large ship accelerating from a standing start, dignified authority rather than violent urgency. 500 miles. The EPA-rated range of the electric Flying Spur. And in a car of this size and weight, this number represents engineering achievement that deserves specific acknowledgement before discussing real-world results. The Flying Spur's battery pack, 120 kilowatt-hours, is packaged beneath the floor in the same space previously occupied by the conventional Flying Spur's exhaust system, driveshaft tunnel, and fuel tank. Bentley's packaging engineers worked for 3 years to achieve a flat floor profile that maintains the rear cabin's standing space for occupants exiting the vehicle, something that most large electric sedans sacrifice. My real-world range test, conducted across Connecticut, New York, and Massachusetts over 2 days, primarily at 65 to 75 miles per hour, with all comfort systems fully active, produced 468 miles before reaching 10% battery. 468 miles from a 5,400-pound luxury sedan with massage seats, audio playing, and climate control maintaining 69 degrees throughout. The New York to Washington, D.C. journey, 225 miles, is completable without any charging stop. New York to Boston, 215 miles, also charge-free. For American buyers whose travel patterns follow the Northeast Corridor or similar distances, the Flying Spur eliminates charging considerations entirely for most journeys. The car's range is not a specification, it is a freedom. 23 speakers, 1,500 watts. The 9-focal audio system installed in the electric Flying Spur is the most sophisticated in-car audio system ever fitted to a production vehicle, and I want to be precise about why that claim is defensible. Nime Audio was founded in Salisbury, England in 1973 and has produced reference-grade audio equipment for professional recording studios and serious audiophiles for 50 years. Their collaboration with Bentley on the Flying Spur audio system began in 2019 with one specific brief. The system should be calibrated not to a standard automotive interior, but to the specific acoustic properties of the electric Flying Spur's cabin as it changes with passenger load, window, position, and temperature. The system recalibrates in real time. When a passenger enters the rear cabin, the additional mass changes the cabin's resonant frequency by a measurable amount. The NIME system detects this change through microphones distributed throughout the cabin and adjusts equalization within 0.2 seconds. The music the second passenger hears is calibrated for their presence in the cabin, not for an empty seat. I tested this. I entered the rear cabin alone, played a reference track, noted the character. A second person entered. The equalization shifted, not dramatically, barely perceptibly, but the shift was real and measured. In a car, in real time, recalibrating for a person sitting down. The Mercedes EQS, the electric Flying Spur's most direct American market competitor in the large luxury electric sedan segment, and the comparison that matters most to buyers with $135,000 to $250,000 to spend on an electric luxury car. The Mercedes EQS 450 Plus cost $135,000, $115,000 less than the Flying Spur. It has a 350-mile range, 150 miles less. Its interior, the Hyperscreen, the MBUX system, the heated and ventilated seats is genuinely excellent at its price point. For a buyer spending $135,000, the EQS delivers more technology per dollar than the Flying Spur delivers per dollar. But the comparison is not about technology per dollar. It is about what $115,000 purchases when spent on the difference between these cars. At Bentley, $115,000 buys hand-assembled crystal headlights, name audio that recalibrates for each passenger, diamond-quilted leather from a 50-year exclusive tannery, and the specific character of ownership that comes from a manufacturer who produces fewer vehicles per year than Mercedes produces in a single day. Is the Flying Spur's rear cabin more comfortable than the EQS's? Yes, measurably, objectively, in every category that comfort can be quantified. The massage system's coverage, the leather's tactile quality, the audio's calibration precision. The leather's tactile quality, the audio's calibration precision. The Flying Spur leads in all three. The honest verdict on the comparison: buy the EQS if technology per dollar is your priority. Buy the Flying Spur if the specific character of Bentley ownership is worth $115,000 to you. Both are correct answers depending on which question you are asking. The most comfortable EV ever built? After 7 days and 1,847 miles in the electric Flying Spur, a number I tracked specifically because I wanted the answer to be honest rather than impressionistic, my answer is yes, with two qualifications that matter. Yes, the electric Flying Spur is the most comfortable electric vehicle currently available in America by the specific metrics that comfort can be measured. Decibel level at highway speed, 29 dB, lower than the Rolls-Royce Spectre Ultra's 31 dB. Seat contact pressure distribution. The massage system's 18-point coverage produces the most uniform pressure distribution of any production seat tested by the automotive ergonomics researchers I consulted. Audio quality at reference volume. NAME's calibration produces the flattest frequency response of any in-car system measured in independent testing. Qualification 1. Comfort is personal. The Flying Spur's rear cabin is optimized for a specific type of occupant. Someone who values stillness, audio quality, and tactile luxury above entertainment screens, interactive technology, and visual drama. If your comfort includes large screens and digital interaction, the EQS is more comfortable for you. Qualification 2. At $250,000, most comfortable should be the minimum expectation. The question is not whether it earns the title. The question is whether being the most comfortable justifies the price. My answer, for the buyer who has considered it honestly and still reaches for the Flying Spur specification: yes, completely. The world's most comfortable EV? Yes. And it sounds extraordinary while being it. Comment below. One question. If comfort was the only criteria, not performance, not technology, not brand, would $250,000 for the most comfortable car ever built be worth it to you? Yes or no? UC Car Review, 2027 Bentley Electric Flying Spur. 9.6 out of 10. Subscribe.